Hello and good evening, CTS265 section 840 students for the fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and this evening's video tutorial is going to be a continuation, the third in a series of 4 videos, where we're taking a supplemental look, supplementing our Chapter 6 lab and lecture, and going a little deeper into IPv6, because this is going to be a critical topic, not just for your success in the course or if you go on to take the route exam, but as you move along in your networking career. IPv6 is definitely becoming more and more popular and will as time goes on. So we've taken a look so far at stateless address auto configuration, or SLAC, where we use the IPv6 auto config command in order to get an EUI64 generated address. We've looked at that on both the Mac, on the Mac side, a MacBook that we have that we're using as a demo here in the background. So here is our Mac right here. As you can see right now, it's completely unplugged. We don't have any addressing information at all. We're going to bring him back online, as well as a 2811 router. And this is the configuration that we actually have right now, our DHCPv6 stateful server. We're going to get this all set up, and this is going to be router 4. And our client, one of the clients, will be a 2811 router here, which is going to be router 8. And then we've got, it says PC, but I'm using a MacBook. And as you can see here, I'm remote desktoped in just to give us a look at the DNS information that we'll pick up. And I'm not going to configure everything we have here. Kind of self-explanatory once we get into the pool. And I just put a crazy prefix in here, /80, to show that it doesn't need to be a /64 when we're doing stateful DHCPv6. And I'll go ahead and name the pool the same thing. We'll put a DNS server in. And in fact, I'll put a couple DNS servers in, along with the NTP server and the domain name of just ccnp.com. All right, so where did we leave off? Well, remember, we were talking about the managed config flag, or the config flags that we would use generally. And remember that the default values are 0 and 0 for both the O flag and the M flag. And so what does that mean? Well, that basically means these two guys, when they're 0, is that we are doing SLAC, and that is the default on Cisco devices. Now, the next set of values that we looked at was where the O flag was set to 1. And what did that mean? Well, when the O flag is set to 1 and the M flag is set to 0, this means we are doing stateless DHCP IPv6, and anticipating that the screen is going to shift here, when we had the O flag at 0 for the O flag, and 1 for the managed config flag. Remember, we said micromanaging, right? Because we're going to be keeping track of all that state information. And then we had the M flag set to 1. This is what we're going to do right now, and this is stateful, right? Because again, with the managed config flag on, that means that we are going to micromanage the DHCPv6 IP address allocations that are going to be randomly generated, right? We're no longer using SLAC to generate the address. You'll see they're not EUI64. We don't find that FFFE somewhere in the middle of a stateful address. But we do provide a prefix and a prefix length, as you could see right over here. Okay, so let's go ahead and dive in. We'll start back up on router 1 right now, which is where we've got some work to do. So we're going to go from privilege exec into global config. We've already got to show run include unicast. I'm pretty sure we have IPv6 unicast routing on. We do. So let's go ahead and take care of the interface first. It's really a 3-step process. So we go into the interface, and remember, we're going to say IPv6 ND managed config flag. And what that config flag is going to do is it's going to notify within the router advertisement that it sends out, it's going to notify candidate DHCPv6 clients that we are doing stateful DHCPv6. And again, this is in the router advertisement that it's sending out. The next thing that we're going to do is we're going to go ahead and, well, under the interface, we won't do that yet. Let me say do show run, and let's and we'll say interface FA00. Let's see what it looks like right now. Do show run interface FA00. All right, so we've got our IP address on there. We've got the manage config flag set. We'll set the pool later. Let's go in. Let's configure the pool first. So IPv6 DHCP pool, and I'll just call it. We'll say IPv6 underscore stateful. Right, we'll leave it at that. Now, remember, with the stateless, we depended upon Slack to do the IP address assignment for us. So, and I shouldn't say assignment, right? We depended upon Slack to basically calculate the IPv6 address. And it was based off the MAC address on the interface of the router, and the router would get the prefix from the server that was sending the router advertisements. So in our case, router 4 was sending router advertisements out to the LAN segment, and the MacBook and the 2811 router, router 8, got those router advertisements, saw that the M flag and the O flag, the other flag and the manage flag, were both set to 0. He knew he was going to be doing Slack, so he took the prefix out of the router advertisement and then used EUI64 on both the MacBook and router 8 to calculate the end IPv6 address that he was going to be, his global unicast IPv6 address that he was going to be using. So with stateful DHCPv6, remember, we're micromanaging. The M flag is on. So router 4 is going to be the stateful DHCPv6 server. He is going to be tracking all of the DHCPv6 information. So let's go ahead and configure the pool here. We need to go ahead now and define an address prefix. And again, I just used a crazy 333445555, and we said, I think I said 6:7::/80. Again, doesn't have to be a 64. I'm going to go ahead and use a /80. And let's put in here DNS server, and I think we said 2001 dead beef 99::99. And we'll say 99:100. In fact, let's put a third one in here. We'll say 200. All right. So there we go. So we've got 3 DNS servers, and that's going to give us some information to look at on the MacBook, where we should see that we're going to be picking all of these DNS servers up. The domain name, let's just say ccmp.com. Keep it simple. And SNTP, we'll set an SNTP server 2001, or we'll just stick with this address here, 100. SNTP, I need to put the address keyword in there, I believe. There we go. All right. So that's good. So let's say do show run section DHCP. So here was the stateless. Oops, sorry. Here was this. I keep getting too close to the screen. Here was the stateless information that we used earlier. Again, when we compare and contrast these two configs, they're identical with the exception of what? And by identical, I mean we've got a DNS server, a domain name, SNTP server. So what's the only difference? You've got it. With stateful, we're going to be handing addresses out from a specific prefix length. And this is it right here. So let me go ahead and say do show run interface FA00. So the final thing we need to do, we've turned the manage config flag on that faces the clients that are out there who are going to be trying to get address information from us. We've configured the DHCPv6 pool. We've put the prefix, the address prefix in there that router 4 will create addresses with and assign to the candidate clients who are going to be our MacBook and router 8. So now let's go ahead, step 3 in the process, interface FA00, and all I say here is IPv6 DHCP server, and we're going to put in here IPv6 underscore, oops, sorry, stateful. Going to be careful there. All right, so we are totally set up right now. And so you can see that we're sending IPv6 type 58 messages out to DHCP, or via ICMP, apologize, via ICMP v6. So here's what the final config looks like. Again, do show run interface FA00. And so there we go. I've got my address assigned. I've got my link local and my global unicast. but I'm also going to be acting as a stateful DHCPv6 server. So I've got the neighbor discovery manage config flag on, and I've got the DHCP IPv6 or IPv6 DHCP server command in here, which references my pool, do show run section DHCP, and it references my pool, which is right here. IPv6 underscore stateful. So let's go ahead, let's get this in motion. I take a look at the MacBook here. Now you can see there's no information on the MacBook. I just plugged the interface in, and I don't believe I have port fast on, so we are going to have to wait for at least a couple of seconds. And we should see something happening here. And I don't want to cut away from this. Again, we are debugging as well. So let me create some space here. We should see some activity shortly, as soon. And you can see right here, it's got the APIPA for IPv4. Again, we've got no IPv4 activity going on. So let's see what happens as soon as it comes up. And the indicator will be over here in the debug. We should see all kinds of action as soon as it gets through the spanning tree, blocking, listening, learning to the forwarding state. And I apologize, I didn't set port fast up, and should have done that. So let's see what happens here. Give it a couple more seconds. We should see something by now. And I'm wondering, we've got it plugged in. So let me see here real quick. Show run in FA00. All right, let me double check my config and make sure IP lowercase v6 stateful and the pool IPv6 underscore stateful. So that's correct. So we should see some activity here. And we are not. All right, so that interface is up. The Ethernet interface, let me double check here. Is this interface, yeah, the Ethernet interface is up. The APIPA came up. So we've got the interface plugged in. All right, so hold on one second here. So this is interesting. Show run interface, or not show run. Show run and then section DHCP. I've got the address prefix configured. The pool is IPv6 STATEFUL. DNS servers are in there. Everything is in there. Show IP. And boy, that took a lot longer. I guess we were waiting for the router advertisement there. Almost the full 3 minutes. I apologize for that. I would have thought that the Mac would have sent a router solicitation, but we didn't see that. So, but we are seeing the activity we're looking for now. And take a look here. There is the DHCP stateful DHCPv6 address we've picked up. As you can see, down to the 7 here, the first 80 bits, and then we've got the last 44 bits. Is that right? 84? No, 128. Sorry. So 80. The last 48 bits are not EUI 64, right? I mean, this is just a randomly generated string here that we've picked up. So if I were to come over here and yeah, we're going to get the unreachable code right now, but what I want to show you is if I say show IPv6 DHCP database, what do we see? We don't see anything in the database. I want to look at actually bindings. So show IPv6 DHCP bindings, we're not seeing anything right now. So we should see show IPv6 DHCP binding, and we don't see anything. So let's go ahead and we should see that binding in there. Let's go ahead and bring the router up over here. Let's bring up router 8, see if we get any better results. So now, from the client perspective, with a router, very simple. I go into interface fast Ethernet 00. I say IPv6 enable to get my link local, and then I say IPv6 address DHCP. And again, with autoconfig, I didn't need to use the IPv6 enable because autoconfig is going to get me a global unicast, but it's also going to automatically give me the link local. Whereas when I say IPv6 address DHCP, right, I'm depending upon the DHCP server for the global unicast, and I need my my link local. So I put in the IPv6 enable, and here it goes. And you can see the detailed DHCP debug that we have here. And take a look. We're getting all the information that we anticipated that we would receive. We've got, and I apologize, it's going to be jumping around here. I should probably, let me kill the debugs here real quick. I'll just say you all. So let's scroll back up, and you can see, just like the stateless, we're getting the option 23 DNS servers, we're getting the option 24 domain name, and the option 31 SNTP server. And this is being communicated, right, from the source, which is FE80::1, and our destination here, we remember that 5298, this is router 8. And so this information is being communicated over to router 8. So let's clear the screen here. And looks like we're receiving router advertisements. So we don't want to receive router advertisements from router 8. So how would we turn that off? Remember, we'll get it right this time. So we'll say IPv6 neighbor discovery, and I think it's RA suppress. So we'll go ahead and suppress the router advertisements coming from router 8, because again, router 8's a client. He doesn't need to receive, or doesn't need to send router advertisements. He only needs to send router solicitation messages so that he can receive router advertisements in response to those router solicitations. And let's see now, show IPv6 DHCP binding. All right, and so we've got a single binding here, and this is going to the D972. So that is definitely the IP address I think we have over here. So let's say do show IPv6 DHCP not binding, sorry about that. Do show IPv6 interface brief. And sure enough, 2 Echo Echo Charlie D972, and that is the binding that we see. And I'm not sure, let's take a look here. Yeah, I'm not sure why we did not see a binding for this guy. Let me see if, and that looks like it's only for IPv4. So let me turn this to manually, and then let me flip it back to link local only, and then to auto magically, and let's see if that makes any difference here on the Mac. Yeah, we should be seeing a binding for that second address. So let me see if I say clear IPv6 DHCP bindings, and let me clear everything. Let's see what happens when we clear everything out. And I'll simply say show IPv6 DHCP binding. So we've got no bindings right now. So let me do this. I'll shut this interface down. Let's see what address we have here. So it's still holding on to that address. I'll say shut. And then let's bring the interface back up with a no shut. And let's see. And I'll click on the debug IPv6 DHCP detail. And the debug IPv6 DHCP neighbor discovery. Sorry, not DHCP neighbor discovery. Neighbor discovery. And let's look at I'm drawing out ICMP. All right, let's see what happens here. So okay, so it's definitely a different address. So you can see it randomly assigns these last 48 bits here because we're a /80 on our address prefix length. And these are different, right? They were different characters before. So let's take a look now and see if, and there we go. And hopefully we've got an update here to, all right, fantastic. And so one last go here. Let me unplug the MacBook and let me plug the cable back in, and this is where we will wrap up with this guy. We'll let this come back up, and this is going to take care of the stateful DHCPv6. We'll take a look right now. You can see we have no DNS servers, and we should end up with 3 DNS servers in there. And I definitely need to turn on port fast, which I will do in between these videos. And the last video we're going to look at, it's actually going to be the stateful DHCPv6, but we're going to be taking a look at the relay agent functionality. So we're going to set up a relay agent. So it shouldn't be long now. There is the APIPA address being assigned, that 169.254, because again, there is no DHCPv4 server available. You can see the neighbor discovery. So that address for router 8 went from the reachable state to the stale state, right? 30 seconds had expired. So it pushes it into a stale state. So if I say show IPv6 neighbor, we take a look at the neighbor cache, and not a good time to look at the neighbor cache as we are rolling here with addresses. So let's come over to the Mac. All right, there we go. We've got an address IPv6. It picked up that DHCPv6 stateful address. Take a look at the DNS, and it looks like it's only going to populate it with the single entry. And so this may be something specific to the Mac. Let's see. Show IPv6 DHCP binding. Yeah, we're still only seeing that single binding. And it's definitely the binding coming off of the Charlie 1 Baker Baker 4 Echo 6 Alpha, which I do not believe is this entry here. It's not. So the Mac's not cooperating. However, I've seen it work before, so that's actually why I'm using the Mac. So and it may have something to do with, again, this sort of bizarre range of addresses that we're using here. However, we're going to go ahead and wrap it up here. So this is your stateful DHCPv6 configuration, right? We took a look at the pool configuration where we put the address prefix range in there, and then the DHCPv6 server, in this case router 4, is going to serve up DHCPv6 addresses in that range to the clients. All right, thanks for watching, and I will see you guys on Monday night.